heard of Einstein? Bose was an Indian physicist.
Oh,
And the boson is a type of particle
right.
that was named in his honor. And you might
Oh,
have heard of the Higgs boson. It's a
yes.
different kind of boson. So,
Right.
so here's what's interesting with a Bose-Einstein condensate. It's a subdivision of condensed matter physics where matter gets very dense and very close to itself. And you can do that by reducing the temperature so that the particles don't vibrate as much.
Gotcha.
Okay? And as you make it colder and colder and colder and colder.
All right.
Okay? Now, here's what's going on.
Yeah.
Okay.
It needs a sweater.
No. And I have to whisper because it might disturb
Yes.
the particles. Okay.
It's a beautiful day here at Augusta. Winds are slightly out of the west as the particles line up on the 18th, and we've got a.
By the way, something about sweaters. If you're the same temperature as the outside air, a sweater will do nothing. It can't warm you.
Wait, if you. Oh my God! Yes, you're right. Yes.
Right. A sweater is not inherently warm.
The sweater is just fabric that's an insulator, really.
Correct. So if you are warmer than the outside, and
Right.
then you put on a sweater, it keeps your warmth in you.
Right.
But if you are the same
temperature
temperature
as the right.
as the outside, you got nothing. Your clothing won't do anything.
But-
The thermodynamics of men and women
Yes.
have never been the same. Yes.
You know, they did a study and they found that women are actually colder.
No, they did a study and found out that the temperatures in office buildings were spec'd for men because it was at a time when only men were occupying the office buildings. And so, yeah, the women end up colder. Had they spec'd it for women, men would be complaining how hot it was.
Okay, you're right. That's why I'm glad I'm a man. No, I'm joking. Do not write. That's called a joke. That's it. Okay? Do not write, because I don't.
Okay, that would have rocked the house in 1987.
It
okay?
would have, right. Let's get back. So these particles, you're lowering the temperature.
Okay, so in quantum physics, every particle is also a wave. Okay?
Holy Jesus. Give me a second, man. Give me a second. Quantum physics, every particle
Is also a wave.
Now, is that because they're vibrating?
It's you want to ask rational questions about a reality that still transcends our common sense.
Okay, gotcha.
Okay.
All right. So what you're saying here is like, these are things you have to accept by suspending your natural understanding or your understanding of the world.
Limited understanding,
Your limited understanding.
brought to you by your own five senses,
Right. I'm saying
honed on the plains of the Serengeti to not be eaten by a lion.
Right.
All right? The universe is vastly more complex than that.
Gotcha.
And involves statements that on the face of it seem like they can't be true,
Counterintuitive, that
but
can't
they
be
are
true,
true.
but
Because
they
your
are true.
intuition is not quantum intuition,
Right.
it's classical intuition.
Right. Yeah. That's what I mean by your natural understanding. It's the
natural,
world
right.
around you. Okay.
Correct.
All right.
All right.
So now let's get back to this.
All right.
Every particle is a wave on the quantum level. Okay.
Correct. All right. And so, on the quantum is also a wave. And so you have a jumble of particles, and they're all doing their thing. You can look at what wave is associated with them, what wavelength, okay? And they're each doing their thing. They're all independent particles, okay? So let's cool them down. As they vibrate less, they have less energy associated with them, and their wavelength grows. Okay?
Okay.
All right. So just hang with me now. I
got you.
I don't want to lose you.
Okay. I'm with
Okay.
you right now. Right now. I got
Okay.
it. Okay.
The characteristic wave of the particle, as it slows down,
Okay.
begins to grow.
Right.
Now, there's what's called the Heisenberg uncertainty principle. Okay.
Right.
Which is the more you know about a particle's position in space, the less you know about its energy. And the more you know about its energy, the less you know about its position in space.
Okay.
Okay? Okay. Now, there's a geeky way to get out of a speeding ticket where the cop stops you and it says, do you know how fast you were going? And you just say, no, that means I'm everywhere or something. There's some stupid quantum, okay, that's surely to get the black man shot.
Right.
And then
There you go. That's how that works.
that's how that works. All right. So anyhow, so you have these particles, and as you cool this material, when I say cold, I don't mean put it down in the freezer.
Yeah,
I'm talking on a
like
Kelvin absolute temperature scale, where 0 is the coldest. We have a whole explainer on that one.
Yes, we do.
Right? I remember.
Right. Yes.
You can get down to 10 degrees and 9, 8, 7, 6, 5, 4, 3, 2, 1, a half a degree, a tenth of a degree, a thousandth of a degree. You just keep getting this colder and colder and colder. And the wavelengths of each of these particles gets longer and longer.
Right.
And you reach a point where all the wavelengths overlap each other for every single particle. Mm-hmm. And they become one.
They've condensed.
They've condensed and become one functioning particle.
Oh, nice.
Okay? They didn't just condense and become a solid thing.
Right,
No. All their waves, which used to be separate and distinct, are now overlapping and resonating with each other.
They're the Voltron of particles.
Okay, I forgot who Voltron is. Who's that?
That's the one where all the little robots come together to make one big giant robot.
There it is. There it is. And what movie was that? What comic book was that?
Voltron.
Oh, Voltron is the story.
Yeah, that's the story.
Okay, that is it. Yeah. So all the particles come together and they become one meta particle.
A functioning metaparticle.
Correct, because they all resonate together at the same time. And this is why you can't think of matter as only particles or waves, all right? Because depending on the situation, they will function as one or the other, and in some cases, both.
Wow.
And so, oh yeah. And by the way, there's a lot of phenomena. That's a Bose-Einstein condensate. It happens like quick. As you drop the temperature, it transitions. Boom. It's basically a phase change in what it is. It's